Welcome to Freshwater Generator Part 10, focusing on marine engineering multiple choice questions. I'm Assistant Professor Manivanan S. Question 1. When vacuum reaches 100%, what happens? The options are A. Salinity decreases, B. Boiling stops, C. Salinity increases due to agitation, or D. System shuts down automatically. The correct answer is C. Salinity increases due to agitation. Question 2. How is excessive vacuum controlled? The options are A. Closing valves, B. Increasing temperature, C. Opening vacuum breaker, or D. Increasing feed water. The answer is C. Opening vacuum breaker. Question 3. Which of the following is a method of water treatment? A. Filtration only, B. Chlorination, C. Heating only, or D. Cooling only. The correct option is B. Chlorination. Question 4. How can vacuum loss in a freshwater generator be detected without a pressure gauge? A. By checking pump pressure, B. By observing boiling in sight glass and suction at vacuum cock, C. By measuring salinity, or D. By checking engine RPM. The answer is B. By observing boiling in sight glass and suction at vacuum cock. Question 5. The principle of a freshwater generator is based on A. Boyle's law, B. Charles' law, C. Decrease in pressure lowers boiling point, or D. Increase in pressure lowers boiling point. The principle is C. Decrease in pressure lowers the boiling point. Question 6. Minimum engine, 2-stroke RPM required to start the freshwater generator effectively is A. 20 RPM, B. 30 RPM, C. 50 RPM, or D. 100 RPM. The correct answer is C. 50 RPM. Question 7. What is the typical seawater pump pressure for freshwater generator operation? A. 1 to 2 bars, B. 3 to 4 bars, C. 5 to 6 bars, or D. 7 to 8 bars. The answer is B. 3 to 4 bars. Question 8. Vacuum required before starting evaporation in the freshwater generator is approximately A. 50%, B. 70%, C. 90%, or D. 100%. The vacuum required is approximately C. 90%. Question 9. A drop in vacuum to around 85% indicates A. System failure, B. Evaporation has started, C. Pump malfunction, or D. Air leakage. A drop in vacuum to around 85% indicates that B. Evaporation has started. Question 10. Acceptable salinity level of produced fresh water is A. Below 50 ppm, B. Below 25 ppm, C. Below 10 ppm, or D. Below 5 ppm. The acceptable salinity level is C. Below 10 ppm. Question 11. What is the function of a salinometer? A. Measure pressure, B. Measure temperature, C. Measure conductivity of water, or D. Measure flow rate. The function of a salinometer is to C. Measure conductivity of water. Question 12. High conductivity in water indicates A. Pure water, B. Low temperature, C. Presence of salts, or D. Vacuum condition. High conductivity in water indicates C. Presence of salts. Question 13. In a convergent nozzle, velocity and pressure behave as A. Velocity decreases, pressure increases, B. Velocity increases, pressure decreases, C. Both increase, or D. Both decrease. In a convergent nozzle, the answer is B. Velocity increases, pressure decreases. Question 14. Main cause of vacuum creation in the ejector is A. High pressure, B. Low velocity, C. Pressure drop at throat, or D. Heat transfer. The main cause of vacuum creation in the ejector is C. Pressure drop at throat. Question 15. One reason for failure to create vacuum in the freshwater generator is A. High temperature, B. Strong pump pressure, C. Leakage in system, or D. Clean pipeline. The correct answer for failure to create vacuum in FWG is C. Leakage in system. Question 16. In FWG, steam is converted to fresh water in A. Evaporator, B. Separator, C. Condenser, or D. Ejector. Steam is converted to fresh water in C. Condenser. Question 17. What removes brine from FWG? A. Distillate pump, B. Air ejector, C. Jacket water, or D. Separator. The component that removes brine from the FWG is B. Air ejector. Question 18. During pressure testing, which valve must be closed? A. Air screw, B. Feed water valve, C. Discharge valve to freshwater tank, or D. Vacuum breaker. The valve that must be closed during pressure testing is C. Discharge valve to freshwater tank. Question 19. Reverse osmosis works by A. Heating water, B. Reducing pressure, C. Applying pressure to force water through membrane, or D. Evaporation. Reverse osmosis works by C. Applying pressure to force water through membrane. Question 20. Typical pressure used in a reverse osmosis plant is A. 5 to 10 bars, B. 10 to 20 bars, C. 40 to 70 bars, or D. 100 bar. The typical pressure used in a reverse osmosis plant is C. 40 to 70 bars. Thank you for watching this video on freshwater generator questions. Thank you for your attention to these important marine engineering topics.